morning, students. So today is our lecture 6 and we are going to begin with fuel cell. The most common type of fuel cell is liquid hydrogen oxygen fuel cell, which was used in Apollo space program also, remember. So far as fuel cell is concerned, you might have heard it gives maximum efficiency. No other cell can give efficiency more than 40 to 50%, but fuel cell, they can give their efficiency up to 70 to 75%. So what are the advantages, apparatus, setup, cell reaction, all that we are going to see in this fuel cell. So it works continuously. Why does it work continuously? Because as long as the reactants and products, they are fed, it will work. So hydrogen is given through anodic compartment, oxygen is fed through cathodic compartment. The cell reaction has aqueous KOH or NaOH, which acts as an electrolyte. So the moment hydrogen and oxygen would react with each other, what is going to happen? Water will form. So no objectionable byproducts. Pollution free working, continuous source of electricity, maximum efficiency. So these are the advantages. Hydrogen is given through anodic compartment, oxygen is given through cathodic compartment, overall formation of water molecule. And how can they be continuously fed? For that only these two porous carbon electrodes are used so that they can be continuously provided over here. The cell reaction, you can see at anode oxidation, hydrogen combines with hydroxyl ion, water is formed. At cathode, oxygen molecule combines with water, form hydroxyl ion. So the overall reaction, the formation of water molecule. So the construction, anode, cathode, cell reaction, this is what asked from fuel cell. And what are the advantages? As I already repeated, it's a continuous source of electricity, no objectionable byproducts, pollution free working and maximum efficiency. Now the last topic of this chapter, corrosion. So you have studied about corrosion earlier also. It is eating away, it is the slow destruction of metals when metals are exposed to atmosphere due to atmospheric oxygen, water vapor, sulfur, hydrogen sulfide, etc. Except gold and platinum. Even silver, when it is exposed to atmosphere, it gets tarnished. Copper has a green coating over there. So almost all metals, when they are exposed to atmosphere, their properties, their activity gets distracted, and that phenomenon is nothing but corrosion. And greater the reactivity of metal, more would be the rate of corrosion. Then corrosion increases in presence of water, in presence of seawater, because electrolytes are there and so on. So basically we have to study in this topic about the electrochemical theory of rusting of iron. So far as iron is concerned and its rusting, as you all know that for rusting of iron to take place, presence of water vapor as well as atmospheric oxygen both are required. At anode, oxidation takes place, Fe loses electron. At cathode, oxygen combines with H plus and so that water is formed over there. What is the source of this H plus? This H plus comes from the water vapor or water vapor in presence of carbon dioxide. It forms carbonic acid. This carbonic acid dissociates into bicarbonate or carbonate ion. So this H plus, it combines with oxygen and once again water is formed. Then the overall reaction is this. This Fe2 plus with oxygen in presence of water vapor forms ferric oxide and H plus. This Fe2O3, it combines with X mole of water and this is the formula of rust. So this is what the mechanism of rusting of iron is, and its diagrammatic representation along with the reaction is very important in 2 marks question generally. This is asked, that explain the electrochemical theory of rusting of iron. Now what are the methods by which the rusting of iron can be prevented? So prevention of rusting of iron. First is barrier protection. So as the name itself suggests, barrier means by keeping a barrier between the surface of iron and atmosphere. So how can we put or keep that barrier? By oiling, greasing, painting, nichrome painting, painting of nickel and chromium, and so on. Second is using anti-rust solutions. So nowadays many solutions are available in market which are used as anti-rust solutions. One more which is not given in all the reference books, that is specified in NCERT, one anti-rust solution is bisphenol. Very, very important. Apart from that, alkaline phosphate, alkaline chromate, etc. As they are alkaline, so they help in removing H plus ion, and so that rusting can be prevented. So alkaline phosphate and alkaline chromate, then bisphenol. These are the anti-rust solutions which are generally used. Third is sacrificial protection. Sacrificial protection, here generally a metal which is more reactive than iron. Suppose scooty, nowadays scooty we use, and if it is painted along with zinc as well as nickel. So if you consider that it is coated with zinc and in second case it is coated with nickel, what happens when there is a scratch? Then iron as well as zinc both are exposed. Even if zinc is more reactive than iron, then how come we use zinc over there? Because zinc helps to prevent iron by getting oxidized first. So zinc will form the oxide first, it will lose electron first, whereas nickel, no doubt, it can be used, it can prevent, but when iron and nickel both are exposed, then who is going to oxidize first? Iron. So therefore, if we use nickel, that is not that useful and beneficial as compared to zinc, because zinc will prevent the surface of iron to greater extent as compared to nickel. And nickel, its reduction potential is minus 0.14 volt, and that of iron is minus 0.44 volt. So naturally you can see that iron is more reactive as compared to nickel. And if you consider zinc, its reduction potential is minus 0.76 volt. So zinc is more reactive. So don't think that it is contradictory. I said greater the reactivity of metal, more would be the rate of corrosion. But still in case of iron we use zinc. Why? Because zinc by getting oxidized first prevents the surface of iron. And the process by which we give the coating with zinc is known as galvanization. This is also very important. That term is known as galvanization. And one more is, which is known as electrical protection or cathodic protection. So in this case especially for submarines and baseline refineries, for them we use electrical protection or cathodic protection of iron. So cathode is meant of iron and the anode will be more reactive metal like magnesium, etc. And so that the surface of iron can be protected or prevented. So these are the measures by which we can prevent the rusting of iron: barrier protection, using anti-rust solutions, sacrificial protection where comes galvanization, and that is electrical protection or cathodic protection of iron. So today we have completed this lesson, electrochemistry, my dear students. We started with voltaic cell, galvanic cell or electrochemical cell. After that, after doing the reaction, mechanism, cell reaction, etc., then Nernst equation, questions based on Nernst equation, relation with free energy, electrode potential, equilibrium constant, and then we studied about electrolysis, what is the mechanism of electrolysis, how does electrolytic cell work, what are the laws of electrolysis, and that is Faraday's laws of electrolysis, first law, second law, applications of electrolysis, and then we started conductivity in electrolytic solutions, and there we studied in detail about molar conductivity, equivalent conductivity, their units, the factors on which molar conductivity depends, how does molar conductivity vary with concentration, graphical representation and mathematical expression as well. And then in our previous lectures we studied about the commercial cell, that is batteries, primary cell, secondary cell, lead storage cell, nickel cadmium storage cell, fuel cell, and finally corrosion or electrochemical theory of rusting of iron. So we have completed electrochemistry. Now you have to complete all the questions which is given in exercise and in text as well. This is a humble request from all of you, my dear students. As it is, we are facing a tough time right now. So take it very seriously and honestly. All of you try to complete the questions, and if you would have any problem, any doubt during our interact session, definitely I am going to clear it out. Thank you very much.